Hello everyone. Today we're diving into the latest and most fascinating discoveries about Comet 13P Atlas, a celestial object that continues to surprise the scientific community and capture the public's imagination. Get ready to understand what is really happening with this interstellar visitor based on solid scientific data and rigorous analysis. We are at the end of October 2025, and Comet 13P Atlas has just passed its perihelion, the point in its orbit closest to the Sun. This critical moment occurred on October 29th and brought with it spectacular phenomena that deserve our detailed attention. To fully understand what is happening, we need to visualize the comet's trajectory through the inner solar system. On October 3rd, it passed at approximately 27 million kilometers from Mars. After that, it continued its journey toward the Sun, reaching perihelion 6 days ago. At that moment, the comet was positioned almost directly behind the Sun, as seen from Earth. This geometric configuration created a significant observational challenge. The intense solar glare effectively hides the comet from Earth-based observers. Even now, on October 31st, although 13P Atlas is not perfectly aligned with the Sun, its extremely faint magnitude, between 13 and 14, combined with the blinding solar brightness, makes it impossible to observe directly from Earth. This is the question that millions of astronomy enthusiasts are asking. The answer requires patience. Based on precise projections of the comet's trajectory and visibility calculations, we will need to wait until approximately November 11th to begin having suitable observation conditions. The comet will become visible during dawn, about 90 minutes before sunrise. Initially, it will be very low on the horizon, which means that any attempt to observe it before mid-November will be extremely challenging, even with proper equipment. As the days pass, the comet will gradually rise in the morning sky, making observations easier. Looking further ahead, there is another important date, December 19, 2025. On this day, 13P Atlas will pass its closest point to Earth. However, it's important to manage expectations. Close in astronomical terms still means 270 million kilometers, an impressive distance that keeps the comet a relatively faint object in the sky. Now we come to the most exciting part of this story, the recent scientific observations that revealed unexpected behaviors of 13P Atlas. Even though Earth-based observers could not directly see the comet during perihelion, modern science has equipped us with extraordinary tools to overcome this limitation. Several space probes and specialized instruments managed to capture crucial data during this critical period. The GOES-19 satellite, the Stereo A probe, and instruments such as the LASCO C3 coronagraphs on the SOHO spacecraft all contributed valuable observations. The coronagraphs, which work by artificially blocking direct sunlight, were particularly useful, revealing the comet that would otherwise have been invisible against the Sun's glare. NASA's Punch mission also captured spectacular images on the very day of perihelion, October 29th. These combined observations allowed scientists to accurately measure the comet's magnitude throughout its approach to the Sun. The measurements revealed a remarkable phenomenon. As 13P Atlas approached the Sun, its magnitude decreased rapidly. In astronomy, a lower magnitude means greater brightness, a concept that often confuses the general public. The comet was literally becoming brighter with each passing day. This accelerated brightening demanded an explanation. Why had the comet suddenly become so much more luminous? Spectroscopic analysis provided the fascinating answer. The comet was changing color, becoming visibly bluer. Observations through the LASCO C3 instruments and the Stereo mission ES coronagraphs indicated that the comet now appeared significantly bluer than the Sun itself. This dramatic color change offered crucial clues about the physical processes at work. ChatGPT dice, the bluish coloration indicates a massive presence of gaseous emissions, particularly from molecules such as C2, diatomic carbon, and possibly NH2, amino radical. This is the characteristic signature of intense sublimation, the process by which solid substances transition directly into gas without passing through a liquid phase. What makes this discovery particularly interesting is the contrast with earlier observations. Before the solar approach, 13P Atlas exhibited a reddish hue, indicating that dust was the primary contributor to its brightness. The shift to blue signifies a fundamental transition. Gaseous emissions now dominate the Comet ES visible spectrum. This transition occurs because, as the comet approaches the Sun, intense solar heat penetrates deeper into the cometary nucleus. Initially, only the surface layers of dust are heated and released. However, upon reaching perihelion, the heat reaches the ice deposits within the nucleus, triggering massive sublimation of water and other volatile compounds. Another intriguing aspect revealed by the observations is that 13P Atlas has developed an extensive gaseous coma, the temporary atmosphere surrounding the Comet AS nucleus. Yet, interestingly, it does not currently display a prominent dust tail. This absence of a significant tail reinforces the conclusion that the Comet's current brightness is dominated by gas emissions rather than sunlight reflected off dust particles. Spectrographic detectors have identified characteristic emissions from OH radicals, hydroxyl, confirming the presence of intense water sublimation. Perhaps the most intriguing aspect of the recent observations is the detection of a non-gravitational acceleration of the comet. But what exactly does this mean? When objects move through the solar system, their trajectories are primarily determined by gravity, the attraction of planets, the Sun, and other celestial bodies. These gravitational forces are predictable and can be calculated with extreme precision using Newton-Ayres laws of celestial mechanics. However, 13P Atlas is moving slightly differently from what gravity alone would predict. This non-gravitational acceleration indicates the presence of additional forces acting on the comet. In comets, this phenomenon is actually quite common and well understood. The explanation for the non-gravitational acceleration lies in what astronomers call the rocket effect. When the comet massively sublimates gases from one side of its nucleus, usually the side facing the Sun, these jets of gas act as natural thrusters, pushing the comet in the opposite direction. It is the same principle that allows rockets to work in the vacuum of space: action and reaction. The ejected gases exert a force that accelerates the comet's solid nucleus. Depending on the orientation and intensity of these jets, the comet can be either sped up or slowed down along its orbit. In the case of 13P Atlas, the massive evaporation of water and other volatiles detected during perihelion is fully capable of explaining the observed non-gravitational acceleration. Measurements of gas production are consistent with the magnitude of the detected acceleration. One question that remains partially open concerns the specific characteristics of 13P Atlas's nucleus. Since we do not have high-resolution images of the nucleus itself, we can only infer its properties through indirect observations. The exact composition, shape, rotation period, and degree of compactness of the cometary material, all of these factors influence how the comet behaves when heated by the Sun. Some comets are relatively spongy, with loosely bound material that sublimates easily. Others are more compact and dense, releasing gases in a more controlled manner. Observations suggest that 13P Atlas may have unique characteristics in its composition or structure that explain the specific pattern of brightening observed. Possibly, initial layers rich in CO2, carbon dioxide, limited water sublimation until the solar heat penetrated more deeply, releasing large amounts of H2O. It's worth highlighting how modern technology tremendously facilitates the study of astronomical phenomena. Artificial intelligence tools now allow researchers to quickly process large volumes of data, instantly translate scientific papers, and generate automated summaries and analyses. The data on 13P Atlas came from multiple independent sources: Earth-observing satellites, space probes dedicated to studying the Sun, and specialized coronagraphs, all converging to paint a coherent picture of the comet's behavior. This multiplicity of sources greatly enhances our confidence in the conclusions. ChatGPT DISA, as 13P Atlas moves away from the Sun and gradually becomes visible to Earth-based observers, we will have increasing opportunities to study it in more detail. The astronomical community eagerly awaits additional data, including possible observations from the HiRISE probe on Mars, which may have captured unique images during the comet's approach to the red planet. Each new observation will help refine our understanding of this fascinating object. Continuous measurements of its trajectory will confirm non-gravitational acceleration models. Spectroscopic analyses will reveal further details about its chemical composition, and photometric observations will track how its brightness evolves as it moves away from the Sun-Earth's heat. The case of 13P Atlas perfectly illustrates why scientific education is so crucial today. With so much information and misinformation circulating on social media, the ability to distinguish evidence-based facts from sensational speculation becomes increasingly important. Did the comet accelerate? Yes, but through well-understood natural physical processes. Did it change color? Yes, but due to gaseous sublimation, not any mysterious phenomenon. Every seemingly unusual observation has a solid physical explanation when examined with proper scientific rigor. This is the power of the scientific method. Careful observation, rigorous analysis, and multiple lines of evidence converging on testable conclusions. 13P Atlas remains a fascinating and scientifically valuable comet, even without invoking extraordinary explanations that would require equally extraordinary evidence. In the coming months, we will continue to track this interstellar visitor as it travels through the inner solar system, collecting data that will expand our knowledge of the nature and behavior of comets, these primitive remnants of our solar system's formation, frozen time capsules connecting us to the cosmic beginnings 4.6 billion years ago.